Okay, so have you ever stumbled upon an idea that's just so perfectly built, so logically clean, that it feels like it has to be true, even if it sounds completely nuts? Well, get ready because we're about to dive into one of the most fascinating and, frankly, one of the wildest theories I have ever come across.
And it all kicks off with this absolute bombshell of a question. What if two of the biggest pillars in modern science, the mysterious stuff that's supposedly holding entire galaxies together, and the very engine of life itself, what if they're both just the same basic mistake? A kind of trick of the light, all because of the limited way we see the universe.
So, how in the world could anyone even begin to connect these two completely separate fields? I mean, cosmology and biology. Well, to figure that out, we've got to look at this radical new framework that says, hey, this isn't a coincidence. It's a deep truth about reality. It literally treats dark matter and Darwin's random chance as two sides of the exact same coin.
All right, so the theory has a name. It's called the TCGS-SEQUENTION framework. Yeah, I know, it's a mouthful. TCGS stands for timeless counterspace and shadow gravity, and sequention is just its biology-focused twin. But honestly, don't worry about the names. What really matters is the crazy logic holding it all together, and that's exactly what we're going to unpack.
Now, this chart looks super technical, right? You see words like core manifold and shadow manifold, but just ignore all that for a second and look at the bottom row. The whole point is that this theory draws a direct one-to-one parallel. It's claiming that what we call dark matter in physics is the exact same kind of illusion as what biologists call chance or random selection. And it says both of these ideas are just artifacts we need to completely get rid of. And this illusion even gets its own special name, a foliation artifact. Now, foliation sounds complicated, but it's really just a math term for slicing something up. The best way to think about it is like a reel of film. The entire movie, every single frame, exists all at once on that reel. But we only experience it one slice, one frame at a time. This theory says our reality is exactly like that. We're mistaking our slice-by-slice view for some grand process unfolding in time. And that simple mistake is what creates these phantoms like dark matter and random evolution. So that naturally leads to the next big question. If our whole reality is just one slice, then what's the whole movie? Let's take a look at the seriously strange, counterintuitive universe this theory is proposing. Okay, so this whole thing is built on four basic rules, or axioms. First, there's a static, four-dimensional block universe that contains everything, past, present, and future all at once. Second, our 3D world that we see and touch, it's nothing more than a shadow of that 4D reality, which then leads to the third point. Time and chance aren't real fundamental forces. They're just illusions created by our limited, shadowy perspective. And finally, number 4, things like dark matter just plain don't exist. They're just distortions, artifacts from that 4D object casting its shadow. This right here is the main metaphor you have to get. Just think about how the 2D shadow of your hand can get all warped and look really weird depending on the light. The theory is saying our entire 3D universe is a distorted shadow of some higher 4D reality. The weirdness we observe, like galaxies spinning way too fast, isn't because of some invisible dark matter. No, it's because of the unseen shape of the 4D object that's casting the shadow in the first place. Now, I know what you're probably thinking. This all sounds a lot more like metaphysics than physics, right? But here's where the theory gets incredibly clever. Its entire defense, its secret weapon, comes from the world of pure mathematics, specifically the fundamental difference between a map and the territory it's trying to describe. So first, you've got the map. In the world of logic, this is called provability. It's everything that a formal system, like math or a scientific theory, can actually prove about itself using its own rules. It's the part you can write down, the finite description of how things work. And then you have the territory. In logic, this is called truth. This is reality itself. It's the complete underlying state of everything, the thing that the map is always trying and, as we'll see, always failing to completely capture. And this shows you the massive gap between them. You see, back in the 20th century, brilliant logicians like Gödel and Tarski proved something absolutely stunning, that any map, any consistent formal system is guaranteed to be incomplete. There will always be truths out there in the territory that the map can never, ever capture. The territory is just fundamentally bigger than any map you can make of it. So, why this huge detour into logic and philosophy? Because this is the aha moment. The whole TCGS sequencing framework is built on the claim that it is a physical version of this exact mathematical idea. Get a load of this. The theory explicitly maps its own concepts right onto these ideas from logic. The mysterious 4D reality, that is the unmappable territory, the complete truth. Our 3D universe that we see, that's just the limited language we have to describe it. And all our scientific predictions and theories, well, those are just our maps, our best attempts, which will always be incomplete pictures of the full 4D territory.
The analysis I'm working from really nails it with this quote. This isn't just some cute metaphor the theorists are using. No, they have deliberately built their entire system to be a physical manifestation of those famous logical theorems, the very ones that proved some things can be true, but forever unprovable. And that leads to a pretty mind-blowing conclusion. The fact that you can never truly scientifically prove the theory's biggest claim, that this 4D reality even exists, well, that's not a bug. It's a feature. They designed the territory to be completely immune to any map we can ever make of it. So, this brings us to the final and most important question. Is this a work of genius, a perfectly logical system that explains everything? Or is it just bad science dressed up in some really clever packaging? Let's see how it's supposed to actually work. Okay, so in normal science, you make a prediction. If your experiment shows you're wrong, your theory's in trouble. But just look at this process. The TCGS framework creates a map, a prediction. If that map doesn't match what we observe, the theory isn't wrong. In fact, it claims victory. It says, aha, we just discovered that our map was too simple for the incredibly complex 4D territory. And then they just revise the map and try again, in a cycle that could literally go on forever. And that right there is the ultimate double-edged sword. The very thing that makes this theory a perfectly airtight philosophical system, the fact that it can't be proven wrong, is the exact thing that makes it a huge problem from a standard scientific point of view. So here's the final verdict from the analysis. The theory's strength? It's a perfectly logical unified system. Its weakness? It creates what's known as an epistemological trap, basically a belief system that's impossible to argue your way out of, because every failure just gets redefined as a new kind of success. Ultimately, it ends up defining the entire job of a scientist as this infinite, impossible quest to map a territory that, by definition, they can never, ever fully know. Which leaves us with this one last thought to chew on. This whole framework might be a masterpiece of logical construction, a completely self-consistent idea. But does that make it good science? It really forces us to ask ourselves, where do we draw the line between a theory that explains everything perfectly, only because it can never be wrong, and a science that actually helps us make real, tangible, falsifiable progress in understanding the universe we live in?